Hello and welcome to the GCSE Science Tutor. Today we'll be looking at Lesson 4, Structure of the Atom. So before we look at the structure of the atom, let's remind ourselves of what an element is. An element is a substance made up of one type of atom only. For example, take the element gold, and we were to zoom in with a really good microscope, we would find that there are gold atoms only. The same with carbon and helium. Both elements made up of just a single type of atom. So what does an atom actually look like? Well, on the previous slides, we had them represented as round circular dots. Now that isn't quite accurate. So within an atom, there are in fact 3 subatomic particles. Just like the word submarine means beneath the water, subatomic means beneath the particle or beneath the atom. The 3 subatomic particles are called protons, electrons, and neutrons. The protons are found in the middle, alongside the neutrons, which are also found in the middle. The middle of the atom is given the name nucleus. The electrons exist on the outside of the atom in shells. So let's look at some characteristics of the 3 subatomic particles. We saw on the previous slide the location of them, and a proton can be found in the nucleus, or the center of the atom. The neutron is also found in the nucleus, and the electron on the outer shells. The relative mass means the mass relative to each other or in comparison to each other. For example, take the mass of a baby. We would give that a mass of 1, and if we were to look at the mass of an adult, we would say it would have a relative mass of, say, approximately 20, because it's approximately 20 times the mass of a baby. So the relative mass of a proton is 1. A neutron has the same mass as a proton, so we also give it a 1. It does not mean that they weigh 1 grams or 1 kilograms. It just means that relative to each other or in comparison to each other, they have the same mass. An electron's mass is very, very small. So sometimes you will see the word negligible used. That just means it's so small that it almost doesn't matter. The charge can be easily figured out if you look at the name. The proton starts with a P, so think positive proton, +1 or +1. A neutron, now don't get this confused with negative neutron, because neutral neutron actually sounds better. So a neutral neutron has no charge, it has a charge of 0. Now the electron is less easy to work out, but if you figure out the proton and the neutron first, you'll work out that you are left with a -1 as the charge on an electron. We can use the periodic table which you are provided with in your exam in order to work out the number of protons, electrons and neutrons for an atom of a given element. Let's take lithium. If we look at the periodic table, there are 2 numbers given for lithium, 7 and 3. If you forget what these numbers mean, remember that the periodic table has a key, and the 2 numbers can be told by the key. The top number is the mass number, and the bottom number is the atomic number, or the proton number given in a bracket. So how do we use these numbers? So let's look at lithium again. Lithium has an atomic number, or a proton number, of 3, as we can see here. It also has a mass number of 7, which is on the top. The mass number is defined as the number of protons plus neutrons. Remember, protons and neutrons are the only subatomic particles with mass. Electrons have negligible mass or very, very small mass, so are not included in this number. The number of protons can be worked out by simply looking at the atomic number, which is 3. The electron number is not mentioned in either of these definitions, but we can assume that because there are 3 positive protons, there must be 3 negative electrons. An atom is neutral overall, so the positives must cancel out the negatives. In order to work out the number of neutral neutrons, I put a 0 there to represent neutral, we must look at both the mass and the atomic number. We know the mass number is protons plus neutrons. If there are 3 protons, we must be left over with 4 neutrons. We simply take away 4 from 3 from 7 to give us 4. So let's have a look at what this would look like in the atom of lithium. So let's take our 3 protons, add them to our nucleus. We have our 4 neutrons also in our nucleus. And we have the 3 negative electrons in the shells here. Here's another example. Let's look at fluorine. Fluorine has a mass number of 19 and a proton number or atomic number of 9. It therefore must have 9 protons, 9 electrons, because the positive protons is the same number as the negative electrons, and neutrons, we simply take the bottom number away from the top number to give us 10. Now it's your turn. Pause the video now and have a go yourself. So with beryllium, we must have 4 protons, 4 electrons, and 5 neutrons. For nitrogen, we have 7 protons, 7 electrons, and also 7 neutrons. Now let's look at ions. Ions by definition are atoms with a charge. They have lost or gained electrons. Boron has a mass number of 11 and a proton or atomic number of 5. It will also sometimes have a positive 3 charge. So let's look at what that means. So working out the number of positive protons is 5, electrons 5, and neutrons 6. However, the plus 3 charge must mean that it has 3 more positives than it does negatives. So the options are we can either add 3 more protons or we can remove 3 electrons. Now, in fact, atoms find it very difficult to lose or gain protons. So it's the electrons number that changes. So rather than having 5 electrons, this ion has 2 electrons. It has 3 more protons than it does electrons. Let's do another example. Oxygen has a mass number of 16 and an atomic number of 8. An ion of oxygen has a -2 charge. So let's work out protons, electrons, and neutrons. 8 protons, 8 electrons, and 8 neutrons in a neutral atom. However, this is a -2 ion, therefore it must have 2 extra negative electrons. So I'm going to cross out the 8 and write 10 instead. So we have 2 extra negative electrons than we do positive protons. Now your turn. Have a go at calculating the proton, electron and neutron number for potassium, calcium and phosphorus ions, given the charges above the symbols. Pause the video now. So for potassium, normally in a neutral atom, we would have 19 protons, 19 electrons and 20 neutrons. However, the +1 charge on this ion indicates that we have an extra positive compared to negative. So therefore, we must remove a negative electron to give us 18 electrons. For calcium, in a neutral atom of calcium, we have 20 protons, 20 electrons, and also 20 neutrons. However, this has a +2 charge, so therefore we must have 2 extra positives than we do negatives. So therefore we must remove 2 negative electrons to give us 18. For phosphorus, we have 15 protons, 15 electrons, and 16 neutrons in a neutral atom of phosphorus. However, the ion of phosphorus has a -3 charge, which means it must have 3 extra electrons, so therefore 18 electrons in total. Let's do a true or false quiz to see what you know. Question 1. The middle of the atom is called the nucleus. That's true. It is called the nucleus. Question 2. In an atom, the protons and electrons are in the nucleus. That's false. We only find neutrons and protons there. Question 3. The atomic number gives the number of protons plus electrons in an atom. That's false. It only tells us the number of protons, by definition. Question 4. The number of protons in a neutral atom is equal to the number of electrons. That's true. They are the same number. Question 5. The charge of a neutron is negative. False. A neutral neutron is not negative. Question 6. The number of protons in an atom of sodium is 23. False. It's 11. We look at the bottom number, the atomic number, for our number of protons. Question 7. The atomic number is also called the neutron number. False. It's called the proton number. Question 8. The charge on an electron is 0. That's false. An electron has a charge of -1. When an atom has lost or gained electrons, it is called an ion. That's false. It's ion, I-O-N. And finally, question 10. The number of electrons in a magnesium ion is 14. This is false. There are in fact 12 electrons in a neutral atom of magnesium, but in a magnesium ion with a +2 charge, it has lost 2 negative electrons to give us 10. The next lesson in this unit, we're looking at Lesson 5, Electronic Structure. Thank you for listening to the GCSE Science Tutor. Please remember to like and subscribe to get further updates on lessons and tutorials.